12.3 trigonometric functions and general angles. But let's call this what it really is, which is the unit circle. That's what this lesson is all about. And that lesson is the most important lesson of trig. So let's get into it. Before we did trig functions of any triangle, but now we're going to do trig functions of any angle. So no matter what angle I give you, so if we have like a chart here, 0, 180, 90, 270, and 360, same thing with radians, you can find the trig function of any of these angles. The way it's going to work is generally going to draw it to be like a triangle. And what that means is this, right? Let's say that's our angle. Opposite is right here. How much you go down, how much you go up and down on your y. Adjacent is right here. How much you go on your x. And then right here is the hypotenuse. A lot of times they write that as r, right? And then x squared plus y squared equals r squared, right? Pythagorean theorem. So if I want to find sine of this, sine of theta, it's opposite of hypotenuse, SOHCAHTOA. Nothing changes. Good old SOHCAHTOA is still here to help us. Right, so sine is opposite of hypotenuse, so it'll be y over r. Will be adjacent of hypotenuse, so x over r. So cosine theta is x over r. And then tan TOA, tan of theta is OA, opposite over adjacent, y over x. So that's how we're going to find, no matter where I draw a little triangle at, no matter what quadrant it's in, it could be in a quadrant over here. We're going to draw a little triangle, go straight down. This will be opposite, this will be adjacent, and this will be hypotenuse. That's the way it's going to work. Now, like I said, this lesson is called a unit circle, and what that means is that the radius is going to be 1. So there's special cases when we're talking about the unit circle. And unit, right, means r equals 1. That has the length of 1, unit. So in that case, when radius is 1, we have sine theta equals y, cosine theta equals x. Tan's the same, but if you notice, tan is y over x, and y is sine, x is cosine. So tan, you can also say, is just sine over cosine. Now, some of this you gotta memorize. Really, I care less about this one right here, and you divide by the radius. This is one I really care about, sine and cosine. Sine is y, cosine's x. How do I remember that? Well, the key is first, you don't have to memorize one of them, because once you get one, you know the other's the other one. And what I do is, I say sine. I know, stupid, but it works. Sine. Sine is y, cosine's x. Okay, so let's do an actual example. Now, this one is not a unit circle, so we're not going to do the r equals 1 thing. We're just going to do a problem. So the way we do these, when they want you to find all 6 trig functions of a point, they give you a point, is let's draw a triangle at the point. So we're going to do this, 6, negative 6, 2, so 1, 2, 3, 4, 5, 6, up 2. So something to that effect. That is negative 6, 2. Again, not a unit circle. So then, how do we draw a triangle? Well, we always draw a triangle the same way, which is you go to the x-axis, straight down or straight up, and you go to the origin. So that's my crappy triangle. The angle to the origin right there is the angle we're talking about. Now we gotta list the sides. Now we went back 6. Notice how we went backwards. That's a negative 6. It says so even on the point, right? Negative 6. You went to the left. If you go to the left, it's negative. If you go down, it's negative. And like a normal graph, you go right, it's positive. You go up, it's positive. We went up 2, so positive 2. Now we have to find the hypotenuse. So we gotta do a quadratic formula. Unlike the Tin Man, this is a right triangle, so we can do it correctly. So a squared, b squared, c squared. So we get negative 6 squared. Remember, when you square negative, it's always positive. I'm gonna get 36 plus 4 equals c squared. So c equals rad 40. I can actually break that down to be, let's see, what, 2 times rad 10? So, right, that's the hypotenuse. And now if I want all 6 trig functions, that part's the easy part. If I want sine of theta, all we gotta do is SOHCAHTOA. SOHCAHTOA. Right? Cosine, tan. Sine is reciprocal of cosecant. Cosine is reciprocal of secant. And tan is reciprocal of cotan. Right, so if I want sine, it's just SOHCAHTOA, opposite of hypotenuse, so opposite over hypotenuse. So 2 over 2 rad 10. Again, you can leave it like that, you can reduce if you want, it's just 1 over rad 10, same deal. Cosine is adjacent, oh it's negative in this case, negative 6 over the hypotenuse, 2 rad 10. And tan is opposite of adjacent, 2 over negative 6. Right, and if I want the reciprocal functions, all we do is do the reciprocal. Reciprocal of this is that. The reciprocal of sine is cosecant. I'm going to flip it, I'm actually cancel out the 2's and just get rad 10. That's a radical 10. Sorry for the ugliness. Right, on this side, I'm going to flip it, I'm going to get 2 rad 10 over negative 6. I'm going to flip it and get negative 6 over 2, which is the same thing as negative 3. But again, you don't have to reduce. Right, and that's the general idea. Right, it's all about finding the 6. Once you draw the triangle, it's just normal we've been doing forever, SOHCAHTOA. So let's do a couple more. So this first one here, 1, 2. So let me draw where 1, 2 is, right? Here's 1, 1, 2. So it's right there. And then we're going to go straight down and then make a triangle with the origin. This is the angle we're talking about. Again, notice we went over 1 and we went up 2. If I wanted to find the hypotenuse, a squared, b squared, c squared, it would be radical 5. And then you just do the 6 trig functions. It's getting a little tedious, I'm going to skip that part. I want to talk about this one, the next two, because they're a little more interesting. So this one's a negative 8 and negative 15. I'm going to say that's a negative 8, and I'm going to say this is negative 15. Right, so negative 8, negative 15 will be right here. And like I always say, right, go straight to the x-axis. So in this case, I actually got to go up to the x-axis. That's to make a right angle. And I'm going to go to the origin. Now, look, I know what my sides are. This is, I went left 8, so negative 8. And I went down 15, so negative 15. Remember, this is your angle. I got to find the hypotenuse. 15 squared plus 8 squared, so 225 plus 64. That is 289. Square root of 289, I think is 17. So I put a 17 right there. Now, I do want to point out in this one, notice I did not put in negative 17, even though it's on the bottom left. It's because the radius, which is also the hypotenuse, is never negative. It's a distance. So we never consider distance as negative. So this line here will always be positive. Always. These can be positive, negative, depending where you go. If you go up, positive, right, positive. You go down or left, those are negative. But hypotenuse, always positive because it's a radius. And then again, here, we'll just do once you get that, you do the 6 trig functions. Okay, let's talk about this one right here. 0, negative 4. So 0, negative 4 is 1, 2, 3, 4. So 0, negative 4. Now, I can't draw a triangle here. Because remember, you're supposed to go straight to the origin. Actually, let me change that color so you can really see it. Right? So that's my point. I gotta go straight to the origin. There's no triangle to draw. You don't go like this. That's not the way it works. Right? You have to go to the origin. You go to the x-axis and origin. In this case, that's one and the same. So there's no triangle in this case. This one's special. This is my x value and my y value. And now this is where we use our formulas. Sine equals y over r. Cosine equals x over r. Tan equals y over x. In this case, right, I'm not going to use these yet because we're still not at a unit circle. This is not a length of 1. This is a length of 4. So in this case, our r is 4. So if I was doing sine, which is y over x, sine e, sine's y, so y over r, cosine is x and sine is y, and tan is y over x, or sine over cosine. So in this case, sine's going to be the y value over the r value, which in this case is 4. So sine of theta equals negative 1. Cosine would be 0 over 4, which is 0. So cosine theta equals 0. And tan would be sine over cosine, or y over x, which would be negative 4 over 0. And you can't divide by 0, so this is undefined. So that's how you do one when it lands on a... Anytime you land, we call those quadrantal angles. Anytime you land on a line, that's how we do it. It's y over x. And if it's not a unit circle, you have to use the r also. So, hey, look, we just talked about this. Right, those are called quadrantal angles. That's when you fall on the axis. So you're going to fall on that line, or that line, or that line. Those are done specially, right? So these are all done by doing sine E, cosine X, and tan is y over x, or sine over cosine. So again, that's the way we're going to do those. Unless it's a unit circle, then we could ignore the r's. And if I was to do something, we did it already, but you go like this, that would be negative 2, 0. My r would also be just be 2. But notice r, never negative, right? It's how far did you go? I went 2 to the left, right? So r is always positive. And you just plug them in, get the answers. Okay, so let's talk about what we're all here to talk about, the unit circle. This is it. Take a second, look at it, take it all in. So this is the unit circle, right? And the whole point of this is we have to know how to find every single value on here, and we're going to use it a lot this semester, next year, whatever class you take next year, using calculus, using everything. You're going to have to know how to find every single value on here. Now I'm going to show you different ways to do it. These ways, honestly, once you get the hang of it, it's not that bad. But either way you do, you have to do some memorization. Now, how does this work? Well, let's say I said I want to figure out what sine of 150 degrees is. So if you have the unit circle, like you said you memorize it, well, we're going to go 150 degrees right here. So we're looking at this thing right there. Sine E, right? Sine's the y value, so you just look at the y value. Sine 150 degrees is 1/2. Right? Same thing if I asked you, what is cosine of, let's see, 5 pi over 3. So I would go to cosine, I'll go to 5 pi over 3, which is right here. Cosine sine E is the y, cosine is the x value. So 5 pi over 3, you got the x value, which in this case happens to also be 1/2. Right? And then you're like, okay, how about tan? So tan, let's do tan of 7 pi over 6. 7 pi over 6 is over here. Remember, tan is y over x, sine over cosine. So you have to put the y value over the cosine value. So like negative 1/2 over negative right 3 over 2. And then simplify it, stuff cancels out, you get this. And that's how the unit circle is going to work. So as you can kind of see, and the whole goal is I want you to be able to, I should be able to say, hey, what is sine of 11 pi over 6? And you can tell me it's negative 1/2. Or what is cosine of pi over 2? And you got to know it's 0. Right? That's going to be the goal. One way to do it is just to memorize its unit circle. That's way one. So here's our different ways. So way one is just literally memorize it. Some people do it. It's never been my way. I can't. That's just too much for me. So what are some other ways? Well, I'm going to show you 2 other ways. I'm going to show you the table way, which requires a little bit of memorization, but everything you can do here is going to require a little bit of memorization. But it's all about building a table. And once you build the first row of the table, which is actually kind of easy to do, then it's actually not that bad. And I'm going to show you the way I actually do it, which is the triangle way. This is the way Fregoso does it. It's the way I was taught it. It's my favorite way of doing it, but some people it requires requires you to memorize some things also. So it's kind of a which way do you learn best? Do you like to use a table, or you like to use a triangle, or are you a freak and like to memorize things? So that's the goal. That's what we're gonna do, and let's just get started. So the way the table works is like this. We're gonna put sine, cosine, and tan up here. So it's going to go sine first, then cosine, and then tan. Here are the big angles we care about. So you can kind of see it right here. We're going to care about 0 degrees. And then we're going to care about 30 degrees. We're going to care about 45 degrees. And then 60 degrees. And 90. If you notice, these are also, when we talk about radians, right, the reference angle, these are also the reference angles I only cared about, right? So this is in degrees. If I wanted radians, this would be pi over 6. This would be 0. This would be pi over 6. Right? Pi over 6 always has a 30-degree reference angle. Small slice. Pi over 4. Pi over 3. And pi over 2. And again, that's just part of the table. If we're going to make a table, sine, cosine, tan, 0, 30, 45, 60, 90. Right? This goes up. And this is a radian measure. Again, no matter what you do. So there's some things no matter which way you do it, you have to memorize. You have to know that 30 is pi over 6, 45 is pi over 4, 60 is pi over 3, 90 is pi over 2. Okay, let's go to the big part of the table. And that's this right here. the sine is the most important part. So we have to get sine down. So how does sine work? Well, first it's 0. And then it's 1 over 2. Then it's 2 over 2. And then it's 3 over 2. And then it's going to be 1. Now, these are actually not corrected. It's rad 3 over 2 and rad 2 over 2. But that's the way it goes. It's 0, 1/2, rad 2 over 2, rad 3 over 2, 1. But that's how I memorized it. It's 0, and then 1 over 2, 2 over 2, 3 over 2, and then 1. If you're wondering why these numbers come out, it's actually, these are all radical. It's radical 0 over 2, which is 0. Rad 1 over 2, which is 1 over 2. Rad 2 over 2, rad 3 over 2. And then this would supposed to be rad 4 over 2, which is just 2 over 2, which is 1. But instead of going through all that work, it's memorized 0, 1/2, 2 over 2, 3 over 2, then 1. If you could get that down, you have the table memorized. Because that is the hardest part of the table. But if you get that down, then the rest of it's easy. Because once you have that, cosine is this flip of it. If you notice, sine and cosine switch. So cosine is just flip it upside down. 1, rad 3 over 2, rad 2 over 2, 1/2, and 0. Tan, don't forget, tan is sine over cosine, y over x. So you just put sine over cosine. 0 over 1 is 0. 1/2 over rad 3 over 2. Little trick, the 2's cancel. You get 1 over rad 3. Some people rationalize it, but I don't care. Rad 2 over 2 times rad 2 over 2. Cancels out, you get 1. Rad 3 over 2 over 1/2. The 2's cancel out again. You just get rad 3. And 1 over 0, you can't do. It's undefined. And that's the table. Again, this sign right here is the most important part. 0, 1/2, rad 2 over 2, rad 3 over 2, 1. And once you get that, you just flip it for cosine, and then tan is sine over cosine. There's actually one more part of the table, and that's very, very important, and that is, we'll talk more about in a second, and that is all students take calculus. This is a positive sign chart. I don't need that anymore. Sign different way. Not that sign. This lets you know where stuff's positive. So like in quadrant 1, they're all positive. In quadrant 2, only sine is. So if you notice up here, the y values are positive, sine values are positive. The other thing's negative. Quadrant 3, both values are negative, but tan would be the ratio, so that makes it positive. So only tan's positive in quadrant 3. And then quadrant 4, if you notice, only the x values are positive. So only cosine is positive. So a short way to memorize that, we just put all students take calculus. There's a lot of different mnemonics for that. Also, Charles crawl or whatever you want to do. All students take calculus is kind of the math standard one. Again, we'll talk more about that in a second when we actually start doing some of these problems. But that's the chart. Before we move on, I'm going to show you my way, which requires triangles and where we get these values from. So again, I don't care which way you do it. A lot of people, half the people like the chart, half the people like the triangle. It makes it kind of confusing. But if you're like, this chart thing makes sense, hopefully, then you just use that. And I'm going to do it both ways in a second. The way I do it with the triangles also requires memorization. So if I'm doing the triangle way, I still have to memorize, the main difference here is that you have to memorize the triangles. So if you remember from geometry, there's two special triangles. There's a 30, 60, 90 triangle and a 45, 45, 90 triangle. I'm going to treat it separately. I'm going to treat it like there's 3 different triangles. For me, there is the 30 triangle. There's a 60 triangle. Again, I know they're the same triangle, but for our purposes, it helps if you think of them as different triangles. And it's a 45, 45, 90 triangle. So, if we're doing this, right, so 30 degrees, opposite 30, 30 is small. 30 is the smallest angle you have here. Opposite 30 is 1. Hypotenuse is 2, and it's actually always 2. And if you remember in trig, what's your remaining side is rad 3. But for the key for me here, guys, is 30. Understand that 30 is small, right? So it gets the 1. Opposite 30 is 1. 60 is big, on the other hand. It's a big number. So 60 gets the rad 3. Hypotenuse is 2, and the adjacent side is 1. How about 45, 45, 90? Well, if you remember, it's a 45, 45, 90 triangle. These are isosceles. So it's like 1 and 1. And the hypotenuse is radical 2. Again, this is straight from geometry. If you remember that, you're going to be good. What are some tricks? So again, if you want to do the triangle way, now this is actually something you should know anyway. 30, 60, 90 triangles are stuff you should know. But if you're going to do this way, you have to know these. You have to have these down pat. You have to know what 30 is 1, rad 3 2, 60 is rad 3 1 2, 45 is 1 1 rad 2. There's a couple of tips and tricks I use. So again, you have to know 30 is 1. It's small, right? And they have to know 60 goes to rad 3. And here's a couple more tricks. Hypotenuse is always 2. Always. If you notice, that's a 2, that's a 2, that's a 2. It's a radical 2, and I'll explain that in a second, but it's a 2. The 2 always goes in hypotenuse. Always. Now, what's with the radical 2? Well, there's always one radical. Right, over here it's 1, 2, rad 3. Oh, it has to be the rad 3. 1, 2, rad 3. It's the rad 3. 1, 1, rad 2. Right, so if you have 1 and 1, I need a radical there, so rad 2. So those are the tricks I use. I just remember 30 is 1, 30 is small, so it gets the 1. 60 is big, so it gets the rad 3. Hypotenuse is always 2. And then there's always one radical. So again, that's the way I do it. Again, if you're having if you have a hard time memorizing those triangles, do the table way. Right? And again, I'm going to do both ways in a second, but that's the way that works. So if you're doing a triangle way, it's really just knowing the triangles and, of course, SOHCAHTOA. That's the one difference. The difference between the table way and the triangle way to memorize unit circle is triangle way you have to memorize the triangles. Table way you have to memorize how to draw the first column of a table. So again, I don't care what you do, I'm going to do it both ways. So let's get into doing this. So how do we evaluate a trig function? Now, my notes are a little messed up here. Let's do sine of 45. Now, the first step of doing this, always, is right here. Now, this is the triangle way, but it works for both. Is you got to draw the angle. You have to know what quadrant it's in. This is why we spent so much time in last class drawing the angle. Very first step is draw the triangle. So you got to know what quadrant it's in. So I'm going to draw a little triangle here. 45 degrees, 0, 90. 45 degrees is the first quadrant. So that's where I'm at. So you have to know that part. You know what quadrant you're in. So if this is 45 degrees, that makes this 45 degrees. So that's the first step. That should be 45. Right? Now, if I'm doing the triangles, which I'll show you next, once I do that, how do we do the triangle method? It's this. If it's 45, I know what the sides are. So again, 45 degree triangle is 1, 1, radical 2. What do I do next? SOHCAHTOA. So we're doing sine. So sine is opposite of hypotenuse. Opposite hypotenuse. 1 over rad 2. That's it. That's literally it. You draw your triangle in the right spot. It's going to be one of these special triangles that you have to memorize. And then once you have that, you know the sides, and then you do SOHCAHTOA. That's a triangle method. Now, I'll tell you right now, it's actually a little quicker the table method once you draw the table. So what's sine of 45 in the table method? Well, here's 45. Here's sine. It's rad 2 over 2. Those are the same numbers, by the way. I know it's a little funky. That's this rad 2 over 2 is this rationalized. If you rationalize this, you get rad 2 over 2. Again, I don't care about rationalization. No one does anymore. But they're the exact same thing. So that's it. The triangle method is draw the triangle, know what the angles are, fill out the sides, SOHCAHTOA. Table method is draw the table. Oh, 45, rad 2 over 2. So let's do another one. Let's do cosine of pi over 6. It's supposed to be a 6. So cosine of pi over 6. So first step, no matter what, is draw this, right? I don't care which way you're doing it, you got to draw this. Pi over 6. Now remember, anytime it's a 1 on top with radians, it's in quadrant 1. So it's be over here somewhere. And if we know pi over 6 should be a 30-degree triangle. So if I'm doing a triangle method, I go straight down to that. If I'm doing triangle method, I should have my size memorized. 30 is small, it gets to 1. Hypotenuse is always 2, and that makes this rad 3. SOHCAHTOA. So SOHCAHTOA. Ka. Adjacent over hypotenuse. Rad 3 over 2. Again, that's a triangle method. Using the table, pi over 6 is right here, is 30 degrees, and then I want cosine, rad 3 over 2. Again, triangle is actually faster if you haven't made it already. Like, oh, rad 3 over 2, it's just there. Okay, let's go cover now. It's the next one. Cosine of 240. And actually, before we do that, I'll get back to cosine 240. I'll put it right here. Don't forget. Before we do that, let's do tan of 120. So tan of 120. So again, no matter what you do, first step is draw it. So here's 0, here's 90, here's 180. 120 is in between these two. Now in this case, it's going to be a little different. Now let me do triangle method first, right? So I'm going to go straight down. You always go straight down. Find the reference angle. Sound familiar, right? 20, 180, those are 60 apart. So that's a 60-degree triangle right there. Now again, if we have our triangles memorized, at 60, it's hard to read that to 60. Opposite 60 is radical 3, because it's big. Hypotenuse is always 2, and then the adjacent side is 1. Now there's a little difference here. Remember we talked about earlier, if you go up, you're positive. If you go to the left, though, this is a negative. You went to the left, so that's a negative. So if I want to do tan, TOA, tan is opposite over adjacent, so rad 3 over negative 1, or just negative rad 3. So that's how you do the triangle method. Draw it, find the angle. We should know the sides by then, opposite over adjacent. Now, this is where the chart method gets a little more fun. So I have tan. It was a 60-degree triangle, so right here. And right here it says radical 3. How do I get the negative? Well, remember our picture was like this? All students take calculus. And our picture we drew was right there. We're in quadrant 2. In quadrant 2, only sign is positive. All the rest are negative. That's why it's A, all students take calculus. In quadrant 2, S is positive. The rest are negative. I had tan. So that's why it was a negative 3. So negative rad 3. Okay, let's do cosine 240. And this one I do only using the chart, just to show you how it works. So again, I got to draw 0, 90. 90 is up there. I could count 180, 270, 360. 240 is in here somewhere. That's why it's so important to draw the chart. So, to draw the picture no matter what. Here's 240. I got another reference angle. They're 180, 240. They're 60 apart. Right? Now, if I'm doing the chart, hopefully, all you have to do is once you get a table, you make a chart once. That's it. Right? You just go, okay, boom, boom, boom. Like if I give you a quiz or a test, you just make it once, and you refer back to it. You gotta know how to make it, though. No cheat sheets in this class. So this will be 0, 30, 45, 60, 90. Right, the way we draw it, the way we build it again, this because it's super important. Sign starts small, 0, 1/2, rad 2 over 2, rad 3 over 2, and then 1. Again, once you get that, that's the hard part. The rest of it's easy, right? Start small, 0, then 1/2, then 2 over 3, then 3 over 3, 1/2, rad 2 over 2, rad 3 over 2, then 1. For cosine, you just flip it. So now this is 1, rad 3 over 2, rad 2 over 2, 1/2, and then 0. tan is the sine over cosine, so 0 over 1 is 0. That, the 2's cancel out, you get 1 over rad 3. These are the same, so you get 1. The 2's cancel out, you just get rad 3. And then you can divide, so undefined. Right? So I built it. Again, hopefully when you do a quiz test or homework, you just do it once and you just refer to it. All you gotta do is build it once and you're good. How do I use cosine of 240? Well, it's 60 degrees. So 60 is right there, and we're doing cosine, so it should be 1/2. Now I guess I'd make sure it's positive or negative. So what do I do for that? All students take calculus. Probably this would have done right here. Anyway, we're in quadrant 3. In that quadrant, that's T, that stands for tan. That means only tan is positive. So I have cosine, so my answer is negative. Negative 1/2. That's the chart method. Again, if you're doing triangles, it would have been negative rad 3, negative 1 and 2, and then cosine is this over this. That's the idea. Okay, let's do some trig ones, some radian ones. Now again, my notes are a little messed up right there. I apologize. So sine of 3/4, 3 pi over 4. Sorry. So 3 pi over 4. The key thing here is how to draw it, how to graph it. Because remember, no matter what you do, you have to graph it. So we spent a lot of time on this before. This is pi. 3 pi over 4. The trick is make this 4 over 4. So if we're going this way, I haven't reached 4 over 4 yet. I'm a little short. I'm actually right here. That's 3 pi over 4. And if I'm doing it the triangle way, over 4 is 45. I have to have that thing memorized. So 1, negative 1, radical 2. Remember, it's negative because I went to the left. It's 1 and 1 because it's 45. Right, and again, negative is important because it went to the left, it's negative. Going up is positive. This is always positive. So sine is so. So opposite of hypotenuse, 1 over rad 2. Triangle method. It's a pi over 4, so I don't have it right there. Here's pi over 4. Sine, rad 2 over 2. Then is it positive or negative? We were in quadrant 2. Hey, we're positive because the only thing that's positive there is sine. Tan of 5 pi over 3. Again, the key thing here is this: could you draw it? Could you draw it? If you could draw it, you're going to be home free. So 0, pi. So the trick here is, again, make this 3 over 3. Now, that's 3 over 3. I need to get to 5. Remember, 1 less is 2, 1 more is 4. So I'm not there yet. I got to go around again. I went here, got to go around again. You just add another 3 over 3, and that gets you 6 over 3, also known as 2 pi. 1 less is 5. 1 more is 7. So that's where I'm in quadrant 4. If I'm doing this the chart way, pi over 3 is right here. So tan would be radical 3. Now all you gotta do is the positive or negative, right? All students take calculus, only cosine's positive. So my tan here should be negative rad 3. That's the chart. Triangle, you have to memorize that over 3 is 60. You have to memorize that anyway. Opposite 60, 60 is big, is radical 3. Hypotenuse is always 2, and this is 1. We're going down, so that has to be negative. This one's always positive, and we went to the right. Tan is TOA. Opposite over adjacent. And that's the gist of this. I'll do a couple more to make sure we got it, and I'll do one that's a couple that are different, but that's the general idea. Okay, so let's do secant of 120, and then we'll talk about a couple of special ones, and then we'll be out of here. Secant of 120. So 0, 180, 90, 120 is in here somewhere. Again, I always got to draw it and find the reference angle. So in this case, 120, 180 is 60 degrees. Secant, the key thing here is this: what's it reciprocal of? And that is cosine. So this is going to be 1 over cosine. Whatever I get for cosine, you just flip it. If I'm doing a triangle method, 60 is big, it's rad 3. Hypotenuse is 2 always. And then this is 1, but you went to the left, so negative. Cosine is ka, adjacent over hypotenuse. So cosine is negative 1/2. That makes secant the flip of that, so negative 2 over 1. Or just negative 2. Again, works the same thing with the table. We're doing 60 degrees for cosine. So here's 60, here's cosine 1/2, and we were in quadrant 2. So only sine was positive, so it makes cosine negative. And then you just flip it. Again, that's just a general idea. I don't care how you do it. Either do a table, or you do triangles. But you gotta practice one way. Okay, let's talk about some things that are kind of special. Let's do 2 more, and then we're pretty much done. We're gonna do sine of pi, and we'll do cosine of 3 pi over 2. So sine of pi. As always, we gotta draw it. Here's 0, here's pi. Sine is right here. Pi is right there. Right, so how do I do it? I can't draw a triangle. This is a non-triangle. This is called a quadrantal angle. It means it falls on the line. That changes the game if you're doing a triangle. If you're doing a table, it doesn't change it that much, but it does change it. So how do we do this if it falls on that? Well, first let me do the table. So 0, let me go up here actually, probably it's a little better. So 0 is right here. So right now we're at pi, which is over there. Anytime you go to the opposite side, you negate it. So if you're up, so it's like, I don't have pi. Pi's not on this list. But if it's on the opposite side, you just make it a negative. So that'll be negative 0, which is still 0. Negative 1, and negative 0, which is still 0. Same thing, how we have pi over 2's right here. But it doesn't have 3 pi over 2. If you negate 3 pi over 2, you just negate it. So you just make it negative. So that's how you do it with the chart. So I'm like, okay, sine of 0. On the chart, sine of 0 is 0. So this one's going to be negative 0, which is just 0. Let's make this sign, make it more interesting. That's what I do it. That's the chart way. How about if we're doing a triangle, right? Well, if you're doing a triangle, you do this. It's a unit circle. You went left 1 to negative 1, 0. It's a normal graph, guys. Here's x, here's y. It's a unit circle. We went left 1, negative 1, 0. And if you remember, sine is 0. That's the idea. Look at this one right here. Sine of 3 pi over 2. I changed it a little bit. Where's 3 pi over 2 at? Right here. So again, if I'm doing the chart doesn't have 3 pi over 2, but it does have 2 pi. Right? 90 degrees has 2 pi. So if I'm doing sine of 2 pi is 1. So sine of 3 pi over 2 is the opposite of that, negative 1. So using the chart, this would be negative 1. Because we don't have 3 pi over 2, but we do have 2 pi. And the chart says sine of 2 pi is 1. So the opposite side would be negative 1. If I'm doing the table, again, if I'm doing the triangle, you can't draw a triangle there. It's on the line. You stop. You have to go, okay, that's a point. We're doing a unit circle. In the unit circle right there, you just went down 1 to normal point. If you go down 1, it's 0, negative 1. Like this is 1, 0. You go up 1, 0, 1. You go to the left 1, negative 1, 0. So I went down 1, and now we're doing sine e. So sine's the y value, negative 1. That's the idea. Like, I know it's a lot to take in. I'm actually gonna stop a little early because I just think it's a lot to take in. But we're gonna practice this in class, and hopefully by the end you'll have a method you prefer and know how to deal with.